Hey guys, in this video we're going to be learning about lesson 1.5, solving compound inequalities. In order to do the next lesson that you're going to have to do after this, you absolutely have to master what we're learning in this lesson. So first of all, I want you to understand how important it is that you master the topics we're studying in this video. So our learning target is I can solve compound inequalities involving the word and. Our next video will involve the word or, but today we're just going to focus on solving compound inequalities involving the word and. So what is a compound inequality? Well, it's really, it's two distinct inequalities joined with the word and or the word or. So we're talking about two inequalities within the same problem. And the word and means the overlap or the intersection of those two inequalities. So please keep in mind that and means overlap or intersection. So looking at this first example, we're supposed to find and graph the solutions of this compound inequality. We see there are two inequalities here within the same problem, and they are joined with the word and, which makes this a compound inequality. So what we're going to do is first treat them like they're two different problems and solve each of them. So I'm going to get the m isolated by adding 4 on both sides. And m is now alone, and negative 3 plus 4 is 1. And when we're talking about inequalities, I really would like my variables to be listed on the left-hand side. So if I turn this around, I want you to notice that the big end of the inequality is pointed toward the m, or you might say the alligator is eating up the m. So I want to keep the alligator eating up the m by turning it around this way. So I get m is greater than or equal to 1. In solving the other one, we're just going to add a 4 on both sides. So here I get m is less than positive 3. So these are joined by the word and. So our solution includes all numbers that are greater than or equal to 1 and also less than 3. So we're going to explore some number lines. So you'll see I've created 3 number lines actually, and what I want to do is graph each of these answers on their own separate number line, and then we're going to talk about what that word and does. So let's take the first inequality. M is greater than or equal to 1. Well, the number 1 would be right here. This could equal 1, so I'm going to close in this dot, or the point, and greater than would include everything shaded to the right of 1 on the number line, including shading the arrow. And let's take a look at the second inequality. M is less than 3. Well, when we just say less than, we're not going to include the number 3. We're just going to include all the numbers that are less than 3. So I'm going to shade everything to the left of 3. So these are the two separate solutions. I want to find the overall solution set, and the overall solution would include wherever these two graphs would intersect if I put them on top of each other. So the word and means the intersection. So I'm looking for, if I put them on top of each other, where they would intersect, and they would intersect everywhere from 1, including 1, up to 3, but not including the 3. Since 3 was not included in that second inequality, it's not included in the overall solution either. So this is my overall solution here. All the numbers from 1 to 3. So I'm going to show you a few ways to express the answer. One way is graphically, as you see here, on the number line. Another way is m includes all the numbers in between 3 or 1 and 3, with least number on the left, greatest number on the right, and we know that it could also equal the 1. And we could also use what's called interval notation. Interval notation would put a closed bracket at 1 and would go up to positive 3, but not include the 3. So there are 3 correct ways of showing the answer here, and one correct answer is the graph. Here is the algebraic answer, and here is the answer written as an interval. When we write intervals, we use a square bracket if that value is included in the solution, and we use a curved bracket if that value is not included in the solution. So we're going to take a look at a second example here. Let's start by solving each of these inequalities separately, just like they're 2 problems. So pause the video for a moment and go ahead and solve. So here's what I got when I solved those 2 inequalities. Remember, these are being joined by the word and, so we're going to be looking for the intersection of these answers. And let's take this first one, 2/3 is less than y. Let's rewrite that as y is greater than 2/3. So y is greater than 2/3 and y is less than 6. Let's look at some number lines now. So if we graph the first inequality, y is greater than 2/3, we would say 2/3, oh, it's before you get to 1, so maybe I'm having trouble with that. Okay, I'm having trouble with my pen. But greater than 2/3 includes all the numbers to the right, including the arrow, all the numbers on the number line greater than 2/3. For y is less than 6, we're not including the 6, we're just including all the numbers that are less than 6. So because this is an and compound inequality, we are looking for the intersection, or we could say the overlap between those 2 graphs. So the overall solution would include all the numbers that fall in between 2/3 and 6, because this is where we would see the 2 graphs overlap if we put one on top of the other. So one correct answer would be this graph. Another correct way of writing the answer would be all the values that fall in between 2/3 and 6. I could even put that in set builder notation. Let me show you up here at the top of the screen. Y such that y is, sorry, okay, I messed up here. So let me just try that again. Y such that 2/3 is less than y is less than 6. So that would be a correct way without the lovely scribble in the middle of it. And then the last way we could show this is with our interval notation. This time we have 2 curvy brackets because neither the 2/3 nor the 6 were included in the solution. So 2/3 up to 6. Now sometimes we see a compound inequality involving the word and the and isn't actually there. So first of all, let me say, if you see 2 inequality symbols like we see here, an inequality symbol here, and you don't see a word, you're going to assume this is an and problem, okay? So our goal here is just to get the variable alone in the middle, and what we're going to do in the middle to get the variable alone, we're also going to do on all parts of the inequality. So for example, I see here that my whole middle section is being divided by 3. To undo division by 3, what we will do is multiply every single part of this by 3. So 3 times 15, that's 45. When I multiply the middle section by 3, it just cancels with the denominator, and I'm left with 31 plus k. And then 19 times 3 is 57. So that's the first part. And then second, I want to get the k alone. So I'm going to subtract a 31. So if I subtract a 31, I'm going to subtract a 31 on all parts. So 45 minus 31 is 14. We have our k. And 57 minus 31 is 26. So here we see k includes all the numbers that fall in between 14 and 26, including the 14 and 26. So on our number line here, let's say that 14 is there and 26 is there. We are including both the 14 and the 26 and all the numbers that fall in between those. So here is one example of a correct solution. We could write this in set builder notation, k such that 14 is less than or equal to k is less than or equal to 26. Or we could write this as an interval. We're including a 14 and we're going up to a 26 and we're including that. I want you to take a moment and try example 4 on your own. Pause the video, try this, and then play the video again and I'll show you the answer. So pause now. So you may have gotten to this point and gotten a little bit confused because this says -7 is less than x and x is less than -12. Well, if that's true, then that would mean that -7 has to be less than -12. But -7 isn't less than -12. We know that -12 is actually smaller. If we explore this on a number line, it makes a little bit more sense. So let me draw some number lines. So I've just approximated here where -7 and -12 may fall on a number line in relation to 0. So if we'll take a look at the first number line, we would have to graph the first inequality. Well, that says -7 is less than x, or we could say x is greater than -7. So greater than -7 would look like this. -7 is not included, and we shade everything that is bigger than -7. The second inequality says that x is less than -12. So it would not include the -12, but it would include everything less than that, which includes everything to the left of -12. Because this is assumed to be an and compound inequality, when I told you when the word is missing, and it's just written with all of these inequalities put together, this is an and inequality. We're looking for the intersection of the two graphs. Well, if I take the blue graph and I put it on top of the black graph, they're actually never going to intersect. So we would say that there is no solution, or the solution is actually the empty set. This last example, example 5, says to earn a B in your algebra course, you must achieve an unrounded test average between 84 and 86 inclusive. You scored 86, 85, and 80 on the first 3 tests of the grading period. What possible scores can you earn on the 4th and final test to earn a B in the course? And I hope you caught that we're talking about an average. So that means we're going to be adding up and dividing by how many numbers we add up. So on the test scores, we've scored an 86, an 85, and 80, and it says we're supposed to find what possible scores could you earn on the 4th and final test. So the 4th one we don't know, it's going to be x, and since I'm averaging 4 tests, I'm going to divide by 4. So add those 4 scores up and divide by 4, and it says we want to get a score of a B, which means we have to have an unrounded test average between 84 and 86 inclusive. Between 84 and 86 can be expressed this way. And the word inclusive here, the word inclusive, just means that we are going to include 84 and 86 in these boundaries. So 84 is less than or equal to this average, and that has to be less than or equal to 86 in order to get a B. All right, so I've set this up for you. I would like for you to try to solve this on your own. You're going to have to begin, of course, by finding the sum of these 3 numbers, and then you're going to have to start undoing the math around this x so that you can get x alone in the middle, and then that will help you find the possible scores you could earn on this 4th test to earn a B in the course. So try it on your own. We'll look at it in class together. Thanks. See you in class.